So for this is the test paper for Chettinad Vidyashram. You can see these questions. Okay, this is the question I'm going to solve now. So let's read the first question. 2 point charges placed in a medium of dielectric constant 5 at a distance of r between them experience a electric force F. The electrostatic force between them in vacuum. Normally they give in vacuum, they'll ask in medium. In this sum they have given in medium, they're asking in vacuum. So let's see, electrostatics. So the answer is 5F, because in vacuum, in medium they have given and they are asking in vacuum. If they give vacuum and they ask medium, you will divide it by K. They give vacuum and then they ask medium, you will divide it by K. But they have given in medium, they are asking in vacuum. So you have to multiply it by K, which is 5. So this is the first question's answer. The second question, I'll read the question. Should I go back to that page or no? I'll just read the question. I've shown you the first question paper, so I'll continue to answer the question. The second question is, the electrostatic field required to keep the water drop of mass m just to remain suspended when the charge is 1 electron. So some charge is going to be static. Downward force should be equal to electrostatic force. Electrostatic force is capital E into small e. So capital E into small e is equal to mg. So electric field is mg by E. So that option is B. So let's go to third question. Third question, equal charges of 20 microcoulomb are placed at different points at 0, 2, 4, 8, 16 at the x-axis. Find the force experienced at x is equal to 2. You know, can you see the red color force which is at 2, which to left to right? The purple color force due to the 20 microcoulomb placed at 4 is from right to left. They both will get cancelled because 20 microcoulomb and 20 microcoulomb distance are also the same. So only F4, F3 and F4 should be added. So just take minus F3 and minus F4 and just add them. What is minus F3 is 9 and 10 to the power 9 into 20 and 10 to the power minus 6 whole square, but distance between 8 and 2 is 6. Distance between 16 and 2 is 14. Rest of it is same. Just take it, solve these two values separately and get the answer. It is 1.2 millinewton. So that's your answer. And the next question is the fourth question. The ratio of the electric field of a shorter dipole at a distance r and 2r from the center along its axial and equatorial line. So you know the axial line is Kp by r cube. Equatorial line formula is Kp by K2p by r cube and Kp by r cube. But here the distance is, the axial line distance is r, equatorial distance is 2r. So replace it as 2r the whole cube. Instead of r, it write as 2r the whole cube. It will become 8r cube. So you can then find the ratio of axial by equatorial. So you'll get 16, because this 8 and this 2 is getting multiplied, 16 is to 1. That's the answer. So let's go to next question. Fifth question. Gauss law is for any closed surface. For any closed surface, regardless of shape or size, it's always for a closed surface. So that's answered. Let's go to sixth question. They have given the electric field as well as potential. They are asking for distance. E is equal to V by D. So distance is 6 meters. That's all. Seventh question. The angle between the electric lines of force and the equipotential surface is always 90, because you know equipotential surface and the electric field lines is always normal 90 degree. So let's go to next question. Eighth question. The square of side A has a charge Q at the center, capital Q, and has small q at the vertices. What is the work done in moving this charge along the diagonal? This will form an equipotential surface. So no work needs to be, you make it into a circle, it becomes an equipotential surface, no work need to be done, so work done becomes 0. So let's go to ninth question. Ninth question, dipole is placed parallel to the electric field. A dipole is getting, the question is, what is the work done in rotating it through 60 degree? Work done is torque is equal to torque into d theta, p sin theta d theta, integrating sin theta, you get cos theta. It's moving from 0 to 60 degree. Okay, 1 second, hold on. See, 1 second, hold on. I am saying torque is equal to P is sin theta, yeah. When theta is the angle between E and P. and the electric dipole moment angle is always from opposite direction of the here theta is they are saying it's parallel. They are saying it is parallel. So theta will obviously be 0, and from there it is rotating through an angle of 60 degrees. So upper limit minus lower limit, you get this answer. This is your P by 2, and so then this is my answer. And the work done rotating through 180 degree means cos 180 minus cos 0. Just substitute and get the answer. Okay, so that completes this. Let's go to next question. So next question is distance of the two plates of the parallel plate capacitor is doubled. The distance is getting doubled and the area is getting halved. Compare the original capacitance with a new capacitance. You know, A by 2 and D becomes 2D, and so then therefore C by 4. So then next question is, you are having n capacitors, all of them connect in series. So 1 by C plus 1 by C, it will become n by C, so C by n. And then they are connected in parallel means NC is equal to, they have given the value, this is 9 microfarad, this 1 microfarad. Let's multiply these two. You get C squared is 9 10 to the power minus 12. C is therefore 3 microfarad. Once you get 3, you can substitute back, you can get n. N is 3. So number of capacitors is 3. I hope you did the sum. Let's go to next question. Next question is the 13th question. Assertion reasoning. So if bob of a pendulum is kept in a horizontal electric field, okay, see, there is a horizontal electric field is like this. The restoring, it will contribute to the restoring force. It will obviously contribute to the restoring force, and so then what will happen? The restoring force will increase, and so then the time will decrease. The time of the pendulum will decrease.
Okay.
Correct? Provided it is a charged bob, it is a charged pendulum. If the question is uncharged pendulum, that will not cause any time change. The time will remain the same. Because if there is no charge, there is no electric field. Neutral body, does electric field, nothing will happen.
Okay.
So then uncharged body, the time is the same for uncharged body. So it's a true and true answer. Okay. So then if the bob is charged and kept in a horizontal electric field, then the time will decrease, because the electric field will come into play only for a charged pendulum. So that completes this question. The next question is 14th question. 14th question. The tire of the aircraft are made slightly conducting so that the charges due to friction will get passed on to the earth. So true. And if the conductor is connected to the ground, the extra charges will get flown. That's also true. That's the right explanation also. So let's go to next question. Assertion: electric potential of earth is taken as 0. No electric field exists on the earth's surface. See, the electric field on the earth's surface is taken as 0. Normally we say electric potential. Normally we say that electric potential at infinity is 0. Generally we say that electric potential at infinity is 0. That is why we find the electric potential on the universe to be negative. I will always say this, electric potential at infinity is 0. That is why the potential that we get here, potential formula is always minus k Z square by r. It's always negative. Why? We understood, because the potential at infinity is what is 0, and at the surface on the space of the earth we take it as negative. But here the question is slightly different. See, basically potential as infinity is taken as 0. That is why we get potential in the space to be always negative. Minus k Z square by r. We always put minus, potential is always negative. But this is an assumption. We can also assume that the potential on the surface of the earth also can be, it is about deciding which is the origin. You can consider the infinity as the sky as the origin, or the surface of the earth also as origin, but considering that it's only hypothetical assumptions that we are making, so the electric potential on the surface of the earth can also be assumed as 0. How they are explaining that? They are explaining that saying, Q is equal to C into V in a capacitor. So C is equal to Q by V, and a surface of the earth has got lot of charge and extensive capacitance. As surface of the earth has got charges. Lightning and all occurring, we have learnt all that, no?
Yes.
So then therefore the capacitance is high, so that the potential is infinitely high. We are considering earth to be a capacitor with infinite capacitance, therefore the potential can be taken as 0. Some explanation like this, and this is quite difficult. It's never been asked in any exam. They seem to have taken it from the internet. So this is what it is, and so assertion is true. And what is the reason that they have specified for this? Let me see. No electric field exists on the surface of the earth. No electric field does. Its charges are existing. When the charges are there, automatically there will be electric field, which will be normal to the surface. Correct?
Yes.
So then that is it. But this is very difficult for me. So let's go to next question, which is the 16th question. 16th question, the answer is electric potential of the so that's done. Electric potential, okay, that's done. 16th question, a work done in moving a charge around the closed path is always 0 because the electric force is a conservative force.
Okay.
So that's true and true. Work done in closed path is always 0 and conservative force only, it will be like that, okay?
Yeah.
So then, so therefore it's true. 17th question. Two charges minus 3q and plus 3q are placed at a comma 0 and 4a comma 0, and this is the origin. You are trying to form what is the electric flux coming out of a sphere? Imagine a sphere of radius 5a. So the sphere is going to be outside. The charge is getting enclosed. The two charges is minus 3 and plus 2. The net charge is minus q. And the flux is charged by epsilon naught. So minus q by epsilon naught Newton meter square per coulomb. This is my answer. Okay, let's go to next question. This is the 18th question. Plot a graph between electric field and as for a sphere. You know, this is for a hollow sphere, the electric field will be 0. Okay. And outside of the sphere is inversely proportional to r square. No, it will be 0. Normally the graph will be like this. It will be directly proportional to r inside the sphere, but provided it's a homogeneous solid sphere, Gauss law. But this is hollow. For hollow sphere, the electric field is 0. So they are only asking for hollow sphere, so you don't have to put that vertical line. So that completes the sum. So let's go to next question, which is the B. Define electric dipole moment is just definitions. Product of either of the charge into separation. And SI unit is Coulomb meter. Let's go to next question. Two charges. 19th question. A hollow sphere of radius 5 cm is charged such that the potential on its surface is 10 volts. What is the potential at the inner surface? It will also be 10 volts because it's a equipotential surface. The entire sphere becomes a equipotential surface, no? Entire sphere. Okay, so then that's about it. Sorry, I deleted the answer. So let's go to next question. It's B. What is the B sum? Draw the geometric shape of equipotential surface due to an isolated charge. Just a positive charge. What is the equipotential surface? So let's go to 20th question. For 20th question, two charges, 3 into 10 to the power minus 8, minus 2 into 10 to the power minus 8, separated by a distance of 15 cm apart. Calculate the point at which where the potential is 0. So we have taken the point at which the potential is 0, some point here, which is xn 15 minus x. And you write net potential 1 by 4 pi epsilon 3 into 10 to the power minus 8 by x plus 1 by 4 pi epsilon. Negative charges should be taken as negative is equal to 0. Then therefore you find x to be 13. Why can't the potential also be 0 to the right side of positive charge? Here also the potential can be 0. Why can't it be 0 here? Let's consider this distance as x. Why can't it be 0 here also? So that was another part of the question which I could have thought I could have done. So then in doing that part, it's the second part of the sum which I'm thinking outside. What is answer? 345 minus 3x is equal to 2x. It's equal to 2x. Sorry, I made a mistake. So then it becomes 5x. 5x is equal to 45. X is equal to 9. Okay, I'm wrong. Okay, so then that. But the thing is, why can't it be potential be 0 here also? Why can't it be 0 outside? In that case, this distance will be x. Okay. So due to this charge, what will be the distance is 1 by 4 pi epsilon naught into the charge is 3 into 10 to the power minus 8 by the total distance is 15 plus x. Plus 1 by 4 pi epsilon naught into this charge which is minus 2 into 10 to the power minus 8 by this distance is just x, can also be 0. Therefore, when you equate this, the negative sign will go away and this gets cancelled. 10 to the power minus 8 get cancelled. You cross multiply, you get 3x is equal to 30 plus 2x. So x can also be 30. X can also be 30. There's one more possibility. There's one more possibility. You didn't do this. Correct. There's one more possibility even outside of the smaller charge. So this is something that you can explore. Make sure that you are finding this X, and that distance to the right of this negative charge can also be potential, can be 0. You would have definitely forgotten that. So that's something you need to answer additionally. Let's go to next question. So it's next question is the 21st question. A comb run through one's dry hair attracts small bits of paper. Why? The comb develops a charge, which is a negative charge, because the hair transfers an electron. So the comb becomes negatively charged, and so when you keep it near the paper, the positive charge comes closer and the negative charge, for the paper the positive charge induced, positive charge comes nearby, induced, and so they are attracting, starts attracting. So let's go to next question. A bird on the high power line doesn't get a shock. Crow is coming and sitting on the live wire. The wire, no?
Yeah,
is it getting shocked? No, because both the feet are at the same potential. Both the feet are at the same potential. Whereas a man standing and touching the live wire, the wire is a higher potential, but my feet is at a lower potential. So current is passing through me and I'm getting a shock. So that's what it is. Let's go to part C. Part C, derive an expression for force and torque on the electric dipole kept in a uniform electric field. You know, torque is equal to P sin theta, that derivation. What about force? Force is just this minus EQ and plus EQ. What else we can say? This is what is this force and this force. That's the force. Two equal and opposite forces. One force is minus EQ, another force is plus EQ, and they both constitute torque, and both of them are answered. Next on the an electric dipole of dipole moment. Dipole moment has been given, theta 30, electric field is given. Just calculate the torque. Make sure you write the unit as Newton meter. Okay, let's go to next question. So this is about a capacitor. One is connected and the same capacitor is also getting disconnected. Connected and disconnected. Next one. So you just have to write this tabular column. Where they are asking about energy density, for disconnected it is E naught by K by K the whole square. So then it will be divided by K square. This is the tabular column which you should answer for connected and disconnected. Now let's go to next question. You verify it later. Okay. Let's go to next question. They asking you to compare a connected capacitor and a disconnected capacitor in which a dielectric slab has been inserted. So that's the answer for that tabular column that I taught in the class. So let's go to 24th question. It's like this, where the area is getting halved. Can you see this is eventually becoming A by 2 only. The parallel plate is only this part and this part, but the distance is doubled. So then 1 by 4 into C naught. Okay, so then next is the second question. This is a very beautiful question. Okay, I'll tell you what. You don't have to write all this. Okay, I'll tell you what. When you place a capacitor, this plate you're giving a charge plus sigma. Automatically, when you place a dielectric medium here, it will get sigma P is the induced surface charge density. They've given in the question. And you know that there will be they're asking you to find what is dielectric constant K. The dielectric constant K is nothing but force in vacuum by force in medium, or electric field in vacuum by electric field in medium. So K is equal to E naught, which is applied existing electric field, by the reduced value of electric field. E is nothing but the reduced value of electric field. Reduced value. Remember, reduced value is E is equal to E naught minus EP. Okay, so you know that K is equal to E naught by E naught minus EP. Correct? And you know that E naught is sigma by epsilon naught. You know all that, right? E naught itself is sigma by epsilon naught. This is also sigma by epsilon naught minus sigma P by epsilon naught. Epsilon naught throughout is getting cancelled. Sigma by sigma minus sigma P. Very, very difficult question. If I had not taught you this, obviously you could not have answered. That's what would have made. If you know this, then probably you could have done. You know this. But it's hard to think of it. This is a reduced value, which is E naught minus EP from the derivation is what I am getting here. That's what makes this sum very beautiful. So let's go to next subdivision. Third question. They are asking energy of the capacitor, not energy density. Energy density means half into epsilon naught into E square.
Okay.
Density is which means you have to multiply it with the volume, because this is not energy density. They are asking energy. This is energy density multiplied by volume will give you energy.
Multiply by we're getting
Energy density has to be multiplied by volume to get the energy, because energy density is energy by volume. Energy by
volume.
So energy is energy density into volume.
Yep.
So you should have the answer multiplied by V in order to write this answer. Next is next subdivision. You have 3 capacitors in series.
Yep.
So I got C by 3. Then that is in parallel with the 2C capacitor. N is 2C.
But they are in series.
They are series, so 1 by 1 by 1.
Oh, yeah.
You took it as R, like resistor.
No, I didn't.
So okay, C by 3. That is in parallel with 2C, so you get the equivalent capacitance. Now you find the charge, total charge. You know potential is V. The total charge is charge Q is equal to C into V. C equivalent into V. This is the total charge which is flowing here. You know this potential, this capacitance is 2C, the voltage is V. You can get this charge Q dash, which is C into V, 2C into V. Subtract it from 7 by 3 CV minus 2. So you get the remaining charge flowing here. And you know that the same charge only will flow here, no? So it's a CV by 3 is flowing, a CV by 3. The ratio of Q dash by Q. So what is it? CV by 3 and a 2 CV on the numerator. Get cancelled, your answer will be 6. The charge through Q dash and the charge through Q. The ratio of it. So can I go to next question? 25th question. Again, the electric lines of force about the positive point charge are always radially outward. Okay, so answer option is A, radially outward, positive charge.
Outward.
Correct? Which of the following statement is true? C is wrong. They are always electric field never form a closed loop. Only magnetic field line will form a closed loop. Only C is wrong. Next question D, both B and C. That is, in the field of two and equal and opposite charge, in the field of two like charge, electric field lines are curved. Only when when two like charges are there, it's getting curved, lateral pressure. Correct? When opposite charges are there, it's positive, it's getting curved. All other places it's not getting curved. Correct? So let's go to next question. In this figure, you know that electric field at A and electric field at B are same because they're the same distance from the positive charge. But at C, if the electric field line is not there, at C there is no electric field line. So then therefore electric field at C is least. So EA is equal to EB is greater than EC. So let's go to next question. This is 26th question. 26th question. Obtain expression for electric field. I didn't answer this because it's only a derivation. Now they are asking for a dipole. What is electric field at the center? For a dipole at the center, can you see due to dipole, the electric field will terminate in negative, emanate from positive. Both of them are in the same direction. So minus 1 by 4 pi epsilon Q by R by 2 minus 1 by 4 pi epsilon Q by R by 2. So the net electric field, you get it in this direction, that will be it at the center. Okay, so let's go to next question. When R is much larger than A, you can say that if it's going to be outside, it's K2P by R cube. You already know this formula. And it's electric field vector, R vector, Newton per coulomb and all you can write if you want to get the center. So last sum is electric field is equal to, no, it's not over, not last sum. Electric field is equal to 10x plus 5, I, along I direction, in which a cube of side L is kept. Side L is kept. Here x and L are in meters. Calculate the net flux. Okay, so let me draw this diagram. So you have a cube like this. Oh no, cube is not like this. Yeah, it's like this only, sorry. So then you have to draw like this, connect it like this, connect it like this, connect it like this, and like this, like this, like this. Yeah, you draw the cube. Let's name it as A, D, B, C, seed 1, D1, D, this is O, this is origin O, and this is A1. Okay, so then look at this, the electric field at this point, let's see, through this phase, electric field is along x-axis, If x is negative, electric field minus, if it's depending on the position, the electric field also can be negative. Let's figure it out. Let's now consider the electric field to be positive for x is positive. For x is greater than 0, electric field is positive. This position, this is of length L. Each side is of length L. So instead of x, you can write L. 10L plus 5 is the electric field coming out of this direction at this for this phase. So flux is going to be, flux is equal to E into ds. What is ds vector? Is no, area vector is normal to the area, and so then they both are parallel. Cos 0. Cos 0 is just 1, and ds is nothing but area. E into area is L square. E itself is 10L plus 5 into L square. Newton per coulomb. This is the electric flux coming out of right side. Electric flux coming out of the left side. Let's see. Electric flux coming out of the left side. This is at the origin. So x itself will become 0. The electric field will be 5. So electric field itself is 5 units. And area itself is again L square. Okay, and Newton per coulomb. And this, in this, the area is going to be normal to the area. But the flux is still positive only. Therefore, theta, cos theta, where is cos theta? Cos theta will be cos 180. And therefore, the answer will be minus 5L square. So, this answer, flux on the left and flux on the right, if I write minus 5L square plus 10L cube, plus 5L square. This and this will get cancelled, I'll get 10L cube as my answer. That will be the net flux, and flux to unit is E dot ds or Newton per coulomb into area meter square. So Newton meter square per coulomb, and that's the flux value. So that's what I would do. I hope I've done it correctly. Any mistakes you can come back and tell me. So let's go to the 27th question, the last sum in the paper. Define electric potential at the point due to a point charge. Electric potential due to a point.
Due to a point charge, work done by curve.
Okay. Define electric potential at a point due to a point charge.
Work done by curve.
It's from infinity to a point. It's electric potential at a point P.
Okay.
Is the work done in bringing a unit positive test charge from infinity to that point. B is equal to W by Q. So electric potential at that point is a work done in bringing a unit positive test charge from infinity to that point.
Okay.
That's what is the definition. Define electric potential at a point, but due to a point charge. Due to a point charge. So this is what I would say.
Okay.
Electric potential at any point due to a point charge will always be the work done in bringing a point charge from infinity to that point. That's all.
Okay.
So let's go to next question. Derive the expression. So of course, I've said unit positive charge. Okay. Derive an expression for electric potential at a point. Okay. Oh, the expression. The expression is this. If you remember, this is A, this is B, and this is dr. Remember, and the electric field is positive due to this point charge. You're going to write its work done is equal to force into displacement, which is dr with a negative sign, and you can write it as potential energy, and E is equal to F by Q. F is equal to E into Q naught into dr is potential energy. You can bring this down, and work done by Q naught can be written as dV is equal to minus E into dr, and E itself is minus 1 by 4 pi epsilon naught into Q by R square into dr. On integrating 1 by R square, you'll get minus 1 by R. Integration of 1 by R square is minus 1 by R. Therefore, the answer will be 1 by 4 pi epsilon naught into Q into 1 by R integrated from RA to RB, because this is your RA and this is your RB. You're bringing it from RA to RB. So, then upper limit is 1 by 4 pi epsilon naught into Q into 1 by RB minus 1 by RA, which is like potential from A to B is VB minus VA. In this, if you take RA minus RB, if the source charge is positive, the potential will also be positive. And so if this point A is going to be infinity and this is going to be r, it's 1 by 4 pi epsilon naught into q by r. Okay, so that's about this derivation. So next question is v versus 1 by r. They're asking you to plot a graph between v versus 1 by r. So it will be a straight line because v is equal to 1 by 4 pi epsilon naught into q by r. So v versus 1 by r means just v versus r means inversely proportional. Very good.
Directly.
Huh? Directly proportional.
Yeah.
Yes, absolutely brilliant. So draw the draw equipotential surface for increasing electric field along z direction. Okay, increasing electric field. Let's take this to be y-axis, x-axis, y-axis, and z-axis. The electric field is going on increasing. Increasing means the equipotential surface is always normal to the electric field. But make sure that increasing means it should become closer and closer. The distance should become lesser and lesser because electric field is going on increasing. If it's uniform means you can space it equally. But it's non-uniform, it's increasing. So then this distance d1, this is distance d2, d1 will be lesser than d2. You should make sure that you write that because it's increasing. D1. It's increasing, not decreasing. So increasing means should be closer and closer. Okay, so that's completing this. And can two equipotential surfaces intersect? No, if it does, it indicates two directions in one point, which is not possible. Give reason. All answers